Hi everyone, my name is Thomas Kim. Today is May 25th, 2019. This is my 19th episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn about STD Promise, STD Future, and what is shared state. If we declare an instance of STD Promise return type, then STD Promise return type dynamically allocates some memory on the pre-store, or is called heap memory. This dynamically allocated memory by STD Promise is shared among different threads. STD Promise has a member function that returns STD future return type. Both STD Promise return type and STD future return type shares the same dynamically allocated memory, or is called shared state. STD future always works together with STD Promise. STD Promise always works together with STD future. Without fully and completely understanding STD Promise and STD future, your journey to the future C++ programming will be a very tough and unpleasant one. Though I cannot promise your future, I can give you my commitment that I will help you brighten your future career as a professional C++ programmer someday. To follow this episode, please visit extension talkplayfun.com website. Click this button to download our source code and watch this video, System Environment Variable Settings. By watching this video, please make system environment variables properly. Otherwise, it might be difficult for you to follow this episode. Also, in my previous episode, passing reference to thread function, you should have to watch this video as well. In this episode, I explained how to pass reference to thread function. If you don't understand how to pass reference to thread function, you may not understand this session. Click this button, Show in folder. If you unzip this file, downloaded file, then you can find the CPP extension folder. Start your Visual Studio Code. If you open this folder in Visual Studio Code, then you can find tutorials folder. Click this button, then click this button. 019 Promise Future CPP. Control B, Control plus. Include talk play fun, output HPP, talk play fun, stream, auto, and there, talk play fun, and there. If you see squiggle on the talk play fun output.hpp, then Control Shift P, edit, configuration JSON. This file opens. Then please put this line of code, CPP extension dir. After inserting this line of code, don't forget comma here. After typing in this line of code, then go to File, Save All, then you can close it, then the squiggle goes away. I create a thread function called void division. The first parameter will be STD Promise int. It should be reference promise. Then parameter is int A, int B. Try, catch. In try block, if b equals to 0, talk play fun, we are throwing exception, throw exception, division by 0. Else we use this promise, an instance of promise, set value. We set return value. We can say set value A divided by B. This is return value of function division. Okay. In this block here, we say promise set exception. Okay, we are setting exceptions like this. STD current exception. It returns current exception. Now our function is done. This is our thread function. Thread function. Now here, void example for promise function future. In this function, I declare STD promise int. Int is return type. Instead, I will declare using return t int. To make it clear, I provide return type here, promise, by declaring an instance of promise. This promise dynamically allocates memory on pre-store. This memory is shared among threads. This memory is called shared state. We can get future from promise like this. STD future return type return t future promise get future. Promise get future returns an instance of future return t, which has a pointer to the shared memory dynamically allocated by STD promise return t. So STD promise return t and STD future return t share shared state. Okay, we can also do like this. We can also do auto future promise get future. Now we create a thread STD thread T. We pass, this is an instance of thread T. We call this function division here. Now we pass promise. Please note that this is reference. We pass promise. In my previous episode, passing reference to thread function, I explained how to pass parameter to thread function division by reference. To pass promise to thread function as reference, we have to use STD allocates. Okay, I explained this concept in my previous episode. Now we are passing two arguments, 8, 2. So it will divide 8 by 2. We create a thread that runs immediately. Now we detach. Thread T should be either joined or detached. Now we detach by detaching a thread, an instance of STD thread. The thread function, in this case, this division runs in the background thread. Now at this point, we can get the return value, try, catch, constant STD, exception, E, stream, E, and here stream 8 divided by 2. We can use future get, and there. Okay, now we call this function. I copied this function name, int main, paste, start your command prompt. We created this file in tutorial folder, dir 019. So we created this file in tutorial folder. We will be using clang std C++17 019 promise underscore future cpp, hit enter. If you see this message, C++ linker command failed exit with one undefined reference to STD once callable, then you have to provide app emulated TLS. You have to provide this command line switch. Hit enter. Now A, hit enter. So it works properly. This division works properly like this. Now we will make another thread. I copy this. No, I will just create STD. We have to create another promise. Return T, failed promise, or failed future, failed promise, get future. Okay, now we create another thread, STD thread, failed thread, division, STD allocates, failed promise 8. Now we divide by 0. Okay, this is division by 0. Don't forget detach, failed thread detach. Now the thread runs in the background. At this point, stream 8 divided by 0 equals failed future get. And there. In this case, it will throw exception. Now let's try clang cls a. Okay, so in this case 8 was divided by 2 properly. In this case 8 was divided by 0. Debug exception file 019 promise future thread id 3 line 13 division by 0. So we caught this exception properly too. This is one of the most canonical form of using STD future, STD promise. This is the canonical use of STD promise, STD future, STD thread. The C++ 2A standard will introduce coroutine, which is based on STD promise, STD future, STD thread. If you have concrete understanding of these things, now you are prepared for your future. Also, STD async, STD packaged tasks are also implemented using STD promise, STD future, STD thread. Without having solid understanding of these fundamentals, all your efforts for C++ multithreading will turn out in vain. Please subscribe to my YouTube channel. Thank you for watching.